Hello guys, welcome to the video. So today we're going to discuss about a problem called maximum depth of a binary tree. So this is like very important and very easy problem from Leetcode which is related to a binary tree. So the given question is they'll be giving you a root of a binary tree. So you need to return a maximum depth of a tree. So here depth in a sense how much deeper you go from the root node to the towards the leaf node. For example, the depth of 9 here is 2 because from starting from the root node which is 1, if you go down it increases by 1, so which is 2. For example, let's find out the depth of 15. So as I've said before, the depth of 3 is 1, right? Starting with 1, we are going down to 20, the depth increases, which is 2. Again, we go down to 15, the depth increases, which is 3. So we cannot go even deeper, right? So that's the reason why uh, the depth of 15 is 3. So for 7, coming from 3, starting from 1, we go down, which is 2. Again, if you go down, it increases to 3. So the depths are uh, 2, 2, comma 3, comma 3. So out of this 3, maximum is 3, right? So we should return 3 as an answer. So that's the reason why the output is 3. So similarly for every binary tree, this is how we calculate a maximum depth. So the way we can do this problem is for the code, what we're gonna do is like we're gonna traverse the entire tree just like a normal DFS approach. So all you need to do is make sure you need to see which is the maximum depth for each node. So while coming to 3, it is 1. While coming to 9, it is 2, right? So you need to change the variable, or you need to make sure like notifying that okay, we got something much maximum depth. So you have to change the maximum depth as 2. Again, if you come to 15, we need to change it as as a 3 because before you have 2, right? Now it incremented to 3, so you need to change it to 3. So this is the approach which we're gonna do now. So coming to the code, they'll be giving you a root of a binary tree, right? For normal data structures problem, they'll be giving you the root of the tree. So with the help of the root, we need to traverse entire tree. So even in this case, we'll be getting the root. So the first thing is we need to create a variable so that we can keep track of the depths of the nodes. So I'll name it as max depth. Initially it would be 0 because the depth wouldn't be negative, right? That's the reason why. So it is very good habit to make sure if at all root is null or not in advance. So if root is equal to null, we can return whatever it requires. Which for this case, if root is equal to null, we just need to return 0. So now if at all root is not equal to null, we can do our entire approach. So for this problem, I'll be using a helper method. I'll name it as GFS. So I'll be passing the root, and more importantly, we need to pass the depth. So initially, if at all root is not equal to null, which means there is at least one node, right? So for this case, let's imagine there is no 9, 20, 15, and 7. So if at all it is only 3, the depth is 1, right? So just pass 1. So coming to the method, so the root is of type tree node. Let's name it root, and we'll keep the depth. So for every whenever we reach a new node or every node, we should keep track of the depth of each particular node in this way using the max depth. Max depth would be math dot max of max depth and the depth of the node. If at all the depth of the node is greater than the maximum depth, then we can directly change it to the maximum depth and the normal pre-order traversal. If at all root dot left is not equal to null, go to left subtree, which is root dot left. And when we go to left subtree or when you go deeper inside, the depth increases, right? So that's the reason why we need to pass depth and plus 1. Similar to the right subtree. If right subtree is not equal to null, go to the right subtree. And even in this case, depth increases, right? So the depth would be depth plus 1. So finally, for when we reach every node, we'll keep track of its depths, and if at all the depth is greater than the previous depth, we'll just store in this maximum depth. So by then when we traverse all the nodes, we'll get our maximum depth into this variable, and then we can directly return it to the answer max depth. So this is the entire code. Okay, let's see if there are any compilation errors. So I'll run the code. Okay, we don't have any errors. The answer is right for the first test case. Okay, I'll submit the code. Okay, it worked. So this is the entire approach, guys. So this is how you'll find the maximum depth of a binary tree. So if you have any doubt, make sure you comment below and make sure you like and subscribe. Thank you.